Local search algorithms in AI are methods used to find solutions to optimization problems where the search space is continuous, meaning it's not limited to discrete values but rather spans a range of values. Here's a breakdown of how local search works in continuous spaces. 1. Objective function. In continuous optimization problems, there's usually an objective function that needs to be optimized. This function maps each point in the search space to a real number representing its fitness or quality. 2. Initial solution. The local search algorithm starts with an initial solution, which can be randomly generated or based on some heuristic. This solution is typically a point in the continuous search space. 3. Neighborhood. Unlike discrete search spaces where neighboring solutions are typically adjacent, in continuous spaces, the concept of neighborhood is defined by a region around a given point. This region can be defined in various ways, such as a fixed distance from the current point. 4. Exploration. The algorithm explores the neighborhood of the current solution to find a better solution. It evaluates the objective function for points in the neighborhood and selects the one with the highest fitness value. 5. Move. Once a better solution is found within the neighborhood, the algorithm moves to that solution and repeats the process. This step is crucial in continuously refining the solution towards an optimal or near-optimal point. 6. Termination condition. The algorithm continues exploring and moving within the search space until a termination condition is met. This condition can be a maximum number of iterations, reaching a certain fitness threshold, or running for a predefined amount of time. 7. Local optima. One challenge in local search algorithms is getting stuck in local optima, where the algorithm converges to a suboptimal solution that is not globally optimal. Techniques like random restarts or simulated annealing can be used to overcome this issue by introducing randomness or allowing uphill moves. 8. Performance and complexity. The performance and complexity of local search algorithms in continuous spaces depend on various factors such as the dimensionality of the search space, the shape of the objective function, and the chosen neighborhood definition. Careful selection of parameters and optimization techniques can help improve the efficiency and effectiveness of these algorithms. Overall, local search in continuous spaces is a powerful approach for solving optimization problems where the search space is not discrete, offering flexibility and scalability in finding optimal or near-optimal solutions.